this online class. Okay, if you have any question during the class, you can ask anytime. But if my voice or my audio or my visual is not clear, please let me know. You just switch on your mic and just share with me if there is a problem with our class. Okay, so far before I continue to our lecture today, today we will discuss about the last section about this chapter 1. We are still in chapter 1. I hope we can finish this chapter. Next week we have to move to the second chapter. It's about the financial mathematics. And then, in other words, there are few students asking about mid-exam. Of course, we are going to have our mid-exam. I think not for this month. Mungkin after semester break. Maybe in May, before maybe before cuti hari raya. Before end of May is cuti hari raya. We have a cuti hari raya. I try to set our mid exam in May, maybe second week or third week of May. I think whatever it is, if I have the date, I will let you know. But at the moment, I hope you can prepare. Please do your revision and do all the exercise for chapter 1. And our mid exam will include topic 1, topic 2, topic 3, and also maybe topic 4. I will decide later. At least three topics. Normally topic 1 until topic 4. But for today, we need to finish topic first. Topic 1 first. Okay. If you have no question, please switch off your mic, just to make sure our recording that there is no distraction on our recording. Okay. Can I proceed, or are there any question? Any question before I proceed?
然后我要一个
Pardon? I can hear you.
我要一个热茶吧，热茶。
If you have no question, please switch off your mic. Otherwise, I will remove you from this class at the moment to make sure there is no distraction in our recording. Okay. Can I proceed? Or any question? Is everything clear?
Yes, doctor, you may proceed. Yes.
Okay, please. Thank you. I hope some of you can respond me, just to make sure everything okay before I proceed. Okay. For today class, please. There is section 1. We have section 1.8, 1.9, and 1.10, if I'm not mistaken, and also 1.11 for application. Okay. For logs, when we talk for logs, what we call it, section 1.8 is about the exponential. It's about the exponential. I still hear some noises here, so I need to remove student first. Okay, again, I remind you, please switch off your mic. Otherwise, I will hear otherwise there is a sound that will distract our recording. Okay. For today topic, I will discuss. I will explain about the exponential function or fungsi exponent. Exponential or fungsi exponent. Before this, I explained about the linear function and quadratic function and system of equation. For today, today I will discuss about exponential and logarithma function. Okay, first, section 1.8 is about the general form of exponential function. What is exponential function? Exponential, we can write as the y equal to bx. Please refer to equation 1.90. Y equal to b to the power of x. We say that y is equal to b to the power of x, y equal to b, y sama dengan b kuasa x, or we can say also y to the exponent of x. We have x power here, b with x power, y equal to b to the power of x, where b must be positive and not equal 1. The value of b must greater than 0, and the value of b must not equal 1. And the exponent of x, the exponent value of x, the value of x can take any number, real number. The value of x can take any number from negative infinity to positive infinity. That is the for x. For what we call it, x is a domain. The value of x, the value of input, the value the input and independent. They can take any value from positive to negative infinity. That's what that mean by the real number. In other words, exponent equation 1.19, y equal to b to the power of x, y equal to fx to the equal to the b to the power of x is also known as the exponential function with base b. The reason why b must be greater than 0, must be positive and not equal 1, is that if b equal 1, 1 to the power of x is also equal 1 for all value of x. So that is equal to the constant function, because the value of b must not equal 1. If b equal 1, the function if b equal 1, that equal to the constant function y equal to 1. And b also must not equal 0, because if y equal to 0 to the power of x, 0 to the power of x is undefined. Undefined for negative value of x. In other words, will be undefined. That's why b must be b must not equal to, must not equal 0, and must not negative. If b is negative, there is b let's say b is less than 0, and then there will be also undefined. That's the reason why b must be positive, but not equal 1. B is greater than 0, and the value of b must not equal 1. For example, we have b equal 2. So this also can be written as y equal to b to the power of x. They're also known as in this case b equal to that is the value the exponential function with power with b equal to with base b equal to. B is also known as a base, asas. Yeah, maybe I forgot to explain about b. What the other name? B is also known as a base. This exponent with base b. If b equal to, we can call this equation as a exponent with base 2. Exponent dengan asas 2. Base or asas. A-S-A-S. Asas. Every exponent must have the base. The base value of the base value is referred to the b. B will represent the base, the asas untuk exponent. Okay. Okay, for example, there is, if you refer to section 1.8.2, there is a rule of exponent. Okay, there is a 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 rule of exponent. There is this rule is very important. We will use this rule for topic 2 and so on until topic 7. But for this class, I hope you can you know how to apply the rule of exponent in order to solve the mathematical equation. Okay, there is just a few rules here. For example, maybe you can we can focus on for example, if in this case let's say, okay, this one. I will focus this one. Y b to the power of negative x. B, let's say y equal to b to the power of negative x. This also equal to 1 over b to the power of x. Because the x is negative, can also be written as y equal to b to the power of negative f. It can also be written as y equal to b to the power of b to the power of x. That is for for example number 3. And then the next one, let's say if you refer to rule number 4, it's a rule number 4. There is b to the power of x and b to the power of y. We assume that there is a same b. In other words, there is same base. The value is equal. For example, we have base equal to 16. Let's see, as you can see here, b equal to 16. Okay, let's say I will please refer to page this page number 40. I will show you this example. Let's say okay, rule number 4. Rule for exponent number 4. Yeah, for example, let's say we have this b, let's say b equal to 16. 16 to the power of 1 over 7 over 4, for example, times dalam 16 over negative 1 over 2. We have b. In this case, b equal to 16. Same base. With we assume b must be equal. The base is equal. Okay, this rule, based on the rule number 4, we can say that we can follow b bx times by. This equal to b to the power x plus y. So in this case, since the base is 16, so the base is equal 16, both have the same value of b, the same base. So this is 16 to the power of 70 plus 4, 7 over 4 plus negative 1 over 2. It is equal to 16 to the power of 7 over 4, 7 divided by 4 minus 1 over 2. So the answer is 16 equal to 5 to the power of 5 to the power of 4. Okay, for this example, okay, this is the answer. You can write this as we can accept this as an answer, but based on this rule of exponent, we can also divide this. Okay, this one we have this answer can be expand into the square root. For example, okay, let's say this we can write this is 16 to the power of 5 in bracket, also to the power of 1 over 2. We can separate this power 5 over 4 into the 16 to the power of 5 in bracket times to the power of 1 over 4. Okay, this 1 over 4. Okay, I hope you can pay your attention here. Okay, this is very important. The exponential concept. 5 to the power of 5, 16 to the power of
Sir, I cannot see your screen.
Yes, any question?
I cannot see your screen.
You cannot see my screen. Okay, how about the others?
I can see the screen.
Then okay. Anyone any other student who cannot see my screen?
I can see it.
You can. Okay, I think maybe for those who have not seen my who are able to see my screen, please log out first and log in again. Maybe you have problem with your line. Okay. Okay, now 16 to the power of 5 can be divided 16 again. 16 to the power of 5 over 4 can be divided into the 16 to the power of 5 times to the power of 1 over 5. Okay, this part to the power of 1 over 5, 1 over 4. Okay, this okay, this one we can change into the square root. To the power of 1 over 4, this is also equal to the square root of 4. Square root of 4. Punca kuasa 4. Root of 4. Punca kuasa 4. Square root, we have punca kuasa 2. Now we have to the root of 4. 1 over 4. But this one, this also can be considered as a final answer. And then the full answer, now we know this is equal to 32. Okay, that's about the rule of exponent with the base b, the same base b. The other rule is about the rule number 5. If you refer to rule number 5, okay, this one, we have exponent b to the power of x divided by the exponent b to the power of 5. Again, we assume they have a same b here. They have a same b here. Okay, in this case, with the same b, okay, this is equal to b to the power of x minus y. Okay, we assume b, they have same value of b to the power x minus y. For example, let's say I have and then maybe another example, x to the power of 3 divided by 8 to the power of let's say to the power of 2, for example. Okay, since we have the same base here, okay, this equal to 8 to the power of 3 over 2 equal to 8 to the power of 1. The answer is 1. Okay, that's the another rule for exponent. Okay, that's just a few rules. I hope you can also, if you refer to this page, the 7 rules for exponent, at least you know the basic rule for exponent, because this rule is very important. We are going to apply this rule, especially in topic 2 and topic 3, when we learn about the financial mathematics. Rule about the interest rate, annuity, and so on in topic 2 and topic 3. Okay, that's the other rule of exponent. Okay, how about the graph? Okay, how about the graph of exponent? Okay, if you refer figure 1.30, okay, there is a graph for exponential function. Okay, basically, the value, as I said earlier, the value of b must be positive. B must be positive. The base must be positive, and the value of b must not equal 1. Okay. The figure 1 show the graph of exponent. The graph of exponent is the graph of exponential function is based on the value of b. Okay, it's based on the value of b. Whether the value of b is between 0 and 1, and whether the value is -1. Okay, basically we can say that the domain of any exponential function, what is the domain? The value of x. X can take any value. The value of x is the value of x is from -infinity to positive infinity. That is the value of x. The domain. Again, the input. The input, and then or we can say the independent value, the value of x, the domain of any exponential. The value of x is from the negative infinity to the positive infinity. But the range, the value of y, the range, the value of y, the value of y must be positive and 0 until positive, negative infinity. In other words, the value of y must be positive. Y must be y is equal or greater than 0. That's why, in other words, the value of y cannot be negative. Okay, the graph has the intercept as y-intercept at 0, 1. Okay, this the basic structure of exponential function. Normally the basic function has a y-intercept at 0, 1. X equals 0, y equals 1. In other words, this shows that when x equals 0, what happens to the function? Y equal to b to the power of 0. The answer is 1. Okay, that is for the x, the y-intercept. This graph has no x-intercept. Okay, the properties number 4. This function, this exponential function, has no x-intercept. In other words, this function, the exponential function does not intersect at y-axis. Tidak memintas paksi melintang. Tidak memintas paksi. Tiada pintasan di paksi x. There is no x-intercept. The graph only have one intercept. That is the x. The intercept is at point y equal 1, x equals 0. They only have x-intercept. There is no x. This graph only have y-intercept. There is no x-intercept. Okay. That is the first 4 properties of exponential, the general properties. But to be specific, if we refer to b, the value of b. Okay, if the value of b is greater than 1, 1.1, 1.2, 2, 3, 4, 5, 6, 7, 8, 9, 10. If the value of b is greater than 1, its value of b is greater than 1, the graph rise from the left to the right. Fungsi tersebut akan meningkat daripada kiri ke kanan. The graph is rise on the left, this one, from this left to the right. Okay, that is for graph when b is positive. And also the graph approach the x-axis. Okay, this area. I refer if b is positive, is greater than 1, the graph approach the x-axis as x become more and more negative. If the value of x is more and more negative, or the value of x decrease from positive to negative infinity, what happened to the graph? The graph will approach by x-axis, but the graph will not intersect, will not tangent, will not tangent, will not touch, or will not cross the x-axis. We only can say that as the value of x decrease, the graph will approach the x-axis when the value of x decrease. As you can see, the tail of the graph of the line will not cross the. There is no intersection at point at x-axis. Same. What happens if b is greater than 0 and 1? If the value of b between 0 and 1. This properties number 6. If the value of b is between 0 and 1, 0.1, 0.2, 0.9, 0.99, and so on. The graph is fall from left to right. The graph is fall. When the value of x increase, the value of y decrease. The value of x, the graph is fall from the left to right. As the value of x increase, okay, in other words, as the x become more and more positive, the value of x increase until to the positive infinity, we can say that the graph approach the x-axis. Again, this graph will not tangent, will not touch, will not, in other words, will not cross the y-axis. That's why if you refer to the property number 4, this the exponent function has no x-intercept. Whether the value of b is between 0 and 1 or greater than 1. So basically, there are two the shape of the exponential function. When you draw the exponential function, make sure we need to identify the value of b first, whether the value of b is between 0 and 1, or the value of b is greater than 1. If the value of b is greater than 1, the graph is rise from the left to right. In other words, when x increase, the y also increase. In other words, maybe we can say there is positive relationship between domain and range between x and y. But if the b is between 0 and 1, between 0 and 1, we can say that we can conclude that the graph is fall from left to the right. In other words, we can say that when the x increase, the value of y decrease. So in other words, there is a negative relationship between x and y. Okay, that's about the graph of the exponential function. So again, the graph of exponential function is depend on the value of b. We need to identify if whether the value of b is greater than 1 or between 0 and 1. Okay, for example, let's say I have this function. If you refer to example 1.4, okay, base b, the exponent function as a base b. Okay, you need we can calculate this value by using the your scientific calculator with base b. Maybe you need to find the button with the power of x. If you refer to your calculator, I think there is one button here, x with a power of 2 or the x to the power of the blank. They have a blank, but x to the power of blank button on your calculator. In other words, you need the scientific calculator to find the answer. I just show you the example. Let's say I have for example, we have exponent with base b. In this case, b equal to b is positive 1. If b is positive 1, the graph is rise from the left to the to right. Okay, for example, if I choose x from -5, -4 until +5, the value of x increase. The value of x increase. What happened to y? The value of y is also increase, because the b is less than y. But when b is 1, at the point when at point x equal 1, sorry, x equals 0. Okay, x equals 0, y to the power of 2 to the power of 0, the answer is 1. That's why this point is also known as the y-intercept. Y-intercept occur at the point when x equal 0. Okay, when we can plot this data. If you refer to figure 1.31, there is the graph for y equal to 2 to the power of x exponential with base b, where b is less than 1. The value of b is greater than 1. Again, okay, there is the intersection. There is a y-intercept. There is a y-intercept. Okay, the next example, okay, that is for b less than 1, between 0 and 1. In this case, b between 0 and 1. So b is between 0 and b is between 0 and 1. Okay, this for example, I have b equal to 0.5. Again, I choose from x for -5 until +5. When x increase from -5 to +5, what happened to y? The value of y decrease. In the case, the value of x increase, the value of y, the value of output decrease from 32 until 0.03125, because the value of b is between 0 and 1. As you can see here, again, when x equals 0, in this case, y equal to 0.5 to the power of 0, the answer is always equal 1. So that is the y-intercept point. Why again? This function, whether basically the exponential function at the same, they have a same y-intercept. That is the y-intercept is 0 and 1. When I plot the graph for this function y equal to bx, again b between 1 and 0, the graph is fall from the left to right. In other words, when x increase and the value of x increase, the value of y will decrease. In other words, there is a negative relationship between x and y. There is the best example of exponential function. In this case, we assume there is a b equal 2 and 1 2 b equal 2 and 0.5. Okay, that's the basic concept about the exponential function. Okay. Now, okay, if you refer to page 44, okay, there is the in other words, you can say that in economy we have exponential with base e. Exponential with base e. If you refer to your calculator, there is button e button or e function base e. What is e? Is the value of e is 2.718 82 blah 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 blah. Or in other words, there's the value of e. In economic, we call it as e exponential with base e. For example, let's say y equal to ex, y equal to e to the power of x. This is the popular, one of the popular equation in economy. We have e to the power of x. Exponent is base e. What is e? E is equal to 2.7182 and so on. Okay. The graph for this function, since e is 2.7 or e is greater than 1. Okay, the graph for y equal to ex. Okay, the graph is rise from the left to right. From the left to right. When the x increase, the value of y is also increase. That is for the exponential function with base e. Okay, that okay, this concept, we will apply this concept in the application. In economy, we also have a economic function with this base. Also in topic 2 and topic 3, we have this function, this base. And then for the last 3 topic, for final exam, we have this. We need this concept. We need this this value in order to find the equilibrium, in order to find the in dy dx or in integration part. There is a unique function in economy. There is a unique function. I will show you in the next topic how to where I will show you that this function has a slope, but the slope is also equal to the value of the function. I will explain later in other topics, maybe topic 6 or topic 7. Okay, that's exponent with base e, and also we have exponent with base e, but the power is negative. Y equal to e to the power of negative x, base e, but the value of b is negative, is between the value of e is 2.7, is greater than 1. But when the power is negative, y equal to the power of negative 5, based on the rule of exponent, this actually equal to y equal to 1 over e to the power of x. That's why when 1 over e to the power of x, the base, the value of the shape of this graph uh, is what we say this graph as the shape of this graph is the graph fall from the left to the right. In other words, when the value of x increase, the value of y, the value of the function decrease, because the power is negative. In other words, since uh, uh, yes, e is greater than 1, but with the negative power, the value of e is uh, is we can assume that this function, this exponent has a negative power, e to the power of negative x. So in other words, when we find the value of y, the value of y decrease when the x increase. In other words, the shape of the graph is fall from the left to the right. In the case, we can assume the value of b, this equal to the situation when the value of b is between 0 and 1. Okay, that's the basic concept of the exponent with base e. Again, the general form of the exponent is y equal to b to the power of x. The value of b must be negative, must be positive, and must not equal 1. And then I hope you can remember that the shape of the exponent is subject to the value of b, whether b is between 1 and 0 or b greater than 0. So in other words, there are two type the shape of the exponent can be divided into the two. It depends on the value of p. So when we want to draw the graph, or you want to solve the equation that has the exponential form, we need to consider consider the value of b first. What is b? Whether the b is between 0 and 1 or greater than 1, because this value will affect the shape of the exponent. Okay, basically that's about the exponential function. Okay, for example, you can refer to page 45. Let's say page 45, the application of exponential function. Okay, normally we are going to apply this concept more in topic 2 and topic 3. But for this, for today, I will just show you 1 or 2 examples how to apply the exponential function, especially in economic and in business. Okay, first of all, I will start with the population growth, pertumbuhan populasi. Okay, how to calculate the population growth? Basically, the population growth is apply the concept of exponent. In other words, we can say the concept of exponent can be used, can be applied for the population growth by using the following formula. Okay, that is the exponential formula, because this equation 1.2, we have the exponent t, 1 plus r to the power of t. That's why we call it that this equation is a exponent. This equation follow the exponent concept, because they have the to the power of t. Okay, please remember, that's why we can say p equal to p0 times 1 plus r to the power of t. Because that's why we have to the power of t. R 1 plus r with t power is 1. It's very important. That's why we call it as the exponential. But since there is for this equation is used to measure the population growth. Okay, as usual, we need to modify the population, the exponential, to suit the equation, the theory with the mathematical theory, to combine the mathematical theory and the economic theory. So for population growth, basically the number of population, the size of population is equal to the size of the population we can say there's a P. P equal to the P0 times 1 plus R to the power of T. Okay, 1 plus R to the power of T. Okay, that is the concept, the formula for the how to measure the population growth. Okay, what is P0? Okay, P0 is number of population in the beginning of year. In the beginning year, size populasi pada tahun permulaan. R is the population growth rate, kadar pertumbuhan populasi. R ialah kadar pertumbuhan populasi setiap tahun. In Malaysia, maybe 1%, 2%, and so on. T number of year, how many year? How many year? In this concept, we want to calculate P. P number, we need to estimate. There is not the real data, the real number. We just estimate the size of the population, the number of the population. In other words, we can say the number of population after the T-year period, selepas beberapa tahun. Slice populasi selepas tahun yang ketiga. Maybe normally at the end of the year. Okay, how to apply this concept? Assume we have this information. Assume that the total population of country X is at 10,000 people with annual growth rate of population is 2%. In this case, at the initial year, at the beginning of year, the population of the country X has the size of the country X. The size of population for country X is 10,000. And then also we assume that every year, annual growth rate mean that every year the inflation is increased by 12%. That mean by the annual growth rate. Kadar pertumbuhan setiap tahun. Setiap tahun populasi diandaikan meningkat pada kadar 2%. For every year we assume that the population is grow by 2% per month. Sorry, per year. So the question is, what is the total population of country X 3 years from now? We need to assume what is number of the population 3 years from now. Selepas 3 tahun. 3 tahun dari sekarang. Same word. Maksudnya sama. Berapakah saiz populasi 3 tahun daripada sekarang ataupun selepas 3 tahun. Okay, in this case, we need the we plan to forecast. We want to forecast the size of the population in future after 3 years. So now we need two information. First, the number, the PO, the number of the size of the population at the beginning, at the origin point. At the first place, what is the size of the population? Let's say the answer is 10,000. And then the second information, we need the growth rate, the annual growth rate, kadar pertumbuhan tahun. In a year, what is the size of the population? Maybe normally we can say that the size of the population normally we can refer to the economic report, or there is this calculation, the annual growth rate of the population show that what happened to the size of the population every year. If the growth rate is positive, we can conclude that the size of the population increased by 2% every year. We just assume that the size of the population increased by 20% every year. So, based on this formula, the size of the estimated size of the population after 2 years, year 1, year 2, year 3. Okay, we have year 1. Okay, the original is 10,000 times 1 plus 0.02 is 2%. 0.02 is 2%. The size, the annual growth rate of the population So for how many years? Okay, say the question asks you for 3 years from now. So we need to put the power of 3. The answer is plus minus 10,000 612. That's the answer. So we can assume that based on the data, during for 3 years, for these 3 years, the size of the population increased by how many people? How many? How about the size of population? The size of population increased by 10,01612 minus 10,000. So the answer for 1 year, the population increased by the 600, and for that 3 years, the inflation is increased by 612. That's how to apply the concept. Okay, the following. Okay, there is another example. I will leave it to you. Please do your revision about the exponential function. Okay, that's all about the exponential function. That's all about the exponential function. Again, for exponential function, we have the general form of the exponential function is y equal to b to the power of x. The value of b can be divided into 2. The first value could be b between 0 and 1. The second one is b is greater than 1. Again, please remember the value of b must not equal negative, and must not equal 1, because that's the properties of the exponent. Okay, I think that's all for exponent. Okay, any question? Anyone can respond? Any question?
No,
No,
Doctor.
nothing.
No question.
Okay, thank you. Okay, now I will proceed to the last question. The section 1.10. That's about the logarithmic function, fungsi log. In other words, we can say that it's a fungsi log, the log function. Okay. Okay. Section 1.10, log function or fungsi log, the logarithmic function. Normally we call it as a log function. Okay. Okay. The gender for log function. Okay. Okay. If we refer to this page 46, the general form for log function. We can say that for the log function, you can refer to equation 1.21, 1.21. There is a general form for a general form of log function, y equal to log b to the power of log b to the power of x. That is the the general form of the log function. But there is a close relationship between log and exponent. In other words, we can say that there is a connection between log and exponent. Because each exponential function has an inverse. Ada songsangan dia. Inverse is songsangan. In other words, we can say that the inverse to the exponential function is a log function. Or in other words, we can say that the log function is also the inverse of the exponential. So that's why they are interrelated. In other words, if we can find log function, we can also find the exponential function. In other words, based on the previous section, we can say fx equal to bx is a exponential function. Or in other words, we can say fx equal to the log b to the exponent of x or to the power of x. This exponential function has a base b, and then the inverse function, the fungsi songsangan, the inverse function of this log function is also called as a log function with base b, or we can say log with base b of x. There is the log function with base b. So we can say here that therefore the log function you can as defined by the equation 1.21, we can write y equal to log bx. In other words, y equal to log base b of x. Y equal to log b. Y equal to log base b of x. Okay, that is the log function. Y equal to log base b with base b of x. That is the log function. Okay, but there is the log function, the exponential function of this log function. Okay, well, if we have this function, there's a log. Now I will show you the connection between log. There is a log and the exponential function. Okay, every log function each log function has an exponential function. If y equal to log bx, the log function, if you want to transform this log function to the exponential, this log function into the exponential, we can write x equal to log bx. So the exponential form of this log function is x equal to x equal to y equal to log bx, x equal to b to the power of y, b to the power of y. That is the relationship, the connection between the log and the exponential function. Okay. Now, if you refer to page example 1.37. Example 1.37. Okay, there is a table. I show you. I show you the log, the log form and the exponential, the exponent form. There are few examples here. For example, let's say I have this log function. Okay, please refer to page 46. Okay, this page 46. Okay, I will show you what does it mean by the log. Let's say I choose one example here, y equal to log bx. So let's say y equal 4, b equal 3, x equal 81 for this case. Let's see for this example. In this case, this y, for this example, we know that y equal 4, b equal 3, x equal 81. X equal 81. So based on the log function, log form, 4 equal to log with base 3, log with base y equal to log base 3 of 81. 4 equal to log base 3 of 81, where y equal 4, b equal 3, x equal 81. Okay, what does it mean? What does it mean by this function? What does it mean y equal to log 3, 81? Okay, in theory, this log 3, 81 means that, in other words, we can say what power we need to raise 3, what power we need, let's say what power, how many times we need to multiply 3. Okay, sorry, how many power, what power we need to raise 3, we need to raise 3 to 81. Raise 3 to get 81. That mean by the log 3. That mean by log 3 of 81. Okay, the answer is 4. We must raise. The answer is 4. We must raise to the 4th power. We must raise to the 4th power. In other words, we need to multiply 3 4 times. 3 times 3 times 3 times 3. That mean by the 3 we must raise to the 4th power, meaning that 3 to the power of 4. 3 to the power of 4. We must raise the 3 to the 4th power to get the answer 81. So in other words, 3 to the power of 4, 3 to the power of 4 is equal to 3 times 3 times 3 times 3. That is the log function. So when we convert this function, this log into the exponent, how to convert? Okay, I will show you. Okay, please refer to this example. Let's see. Okay, let's say, okay, we have the 4 equal to log 381. Okay, how many times we need to multiply 3? How many times? 3 times. How many times we need to multiply 3 to get 81? Or in other words, we can say what power we do have to raise 3 to get 81. The answer is 4. Okay, that is for log. For exponent function, okay, if the log is 4 equal to, let's say 4 equal to log 3 of 81, log base 3 of 81. Okay, what is y? 4 is y. This is a y. B is 3. X equal to 81. Okay, so based on the exponential form, or exponential function, if y equal log bx, x equal b to the power of y. So in this case, 4 equal log base 3 of 81. So 81 x equal to 3 to the power of 4. 3 to the power of 4. That's the exponential form of the log function. What does it mean by 3 to the power of 4? Okay, this equal to 3 times 3 times 3 times 3. We can calculate this equation. 3 times 3 times 3 times 3, we can get the answer is 81. The answer is 81. Okay, that's the exponential and log. Okay, let's look another example. Let's say I have this as a equation, this exponential, this log 3 equal to log 10, log base 10 of 1000. Okay, what does it mean? What power we have? What power we have to raise 10 to get? Sorry, what power we have to raise 10 to get 1000? To get 1000, the answer is 3. So when we convert this log into exponential function, 3 equal to logs 10 of 1000. So 1000 equal to 10 to the power of 3. This equal to 10 times 10 times 10. So the answer is 1000. And that's the connection between log and exponent. Okay. There are another example. Okay, you can refer to this example at table in example 1.37. Okay, there is another equation, log equation. Every log equation, they are exponential function. In other words, we can convert exponential to log and also log to exponential. Okay, any questions so far? Is everything okay?
Okay, doctor.
Okay, that's about the log function. Okay, the next one we have in other words when we write a log function, we have a base, the base b. B again must be positive, between 0 and must be greater than it must be positive. Same to the exponential. Okay, but there are a few for example, if you look at this point, there are 2 points here to show that we have what we call it the two specific value of what we call it okay, exponential. Okay, let's see if you refer to this page. Okay, log with base 10. Okay, log with base 10, log asas 10, log base 10. Okay. For example, let's say we have this kind of log with base 10. In other words, let's say I have this one, y equal to log base 10 of x. Okay, now we call it as a log base 10. Okay, there's a specific, there's a we call it as exclusive, they are exclusive equation, special equation for log. Log with base 10 can also be written as the y equal to log x. No need to write the base. Automatically, when we write log x, we know there is a log with base 10. If you refer to your calculator, you have a button called log. Log means that log base 10. Otherwise, you need to put the base. Maybe base equal 2, 3, and so on. But for base 10, no need to write the base. Okay, so in general, we can say that when you write y equal to log x, we know that the log, the base is b, and the base is equal 10. Okay, the second one, okay, this log we call as a common log. The log we call as a common log. Okay. It is a common log, and then the second one is a natural log. Okay, this is a common log. We call it log with base e. Let's say y equal to log with base e of x. What is e? Again, e is equal to 2 point, as I said earlier, e equal to, if you refer to exponential, e, what is e? Log base e. The value of e is equal to 2.718, and so on. There's e. So for the log with base e, okay, we can write this log, we can convert this log into the ln x. ln refer to the natural log, equal to the natural log. There's a log with base, log with base e. Y equal to log e, log base e of x, or we can convert this equation into the y equal to ln x. Okay, this also known as a natural log. So in this case, meaning that we have two type of two unique equation of log. The first one is a common log, when the base, if the log when b is equal to 10, okay, that is a common log. Natural log refer to the value of b equal to e, 2.718. This is also known as a natural log, or we can convert this log into the y equal to ln. ln is to refer to the log base e. If you ln, if you refer to your calculator, there is a ln button. ln is a log, but log with base e. Whereas the log button is actually for the log with base 10. So there is a two type of log, common log and also natural, and also natural log. Okay, let's look into example how to let's see okay, how, let's say, okay, the next one is about the properties of log. Okay, the properties of log, as you can see on page 47, the properties of log. Okay, I will show you few example here before in example 1.39 until 1.43. The example how to solve the log and exponential function together, because there is a relationship between exponential and log function. Okay, how about the property of log here? Okay, there is a few property of log, 1, 2, 8, 9, 10, 11 properties. Okay, I will show you just a few. Okay, maybe okay, the properties. Okay, if you look the property number 2, okay, we have these properties. Log b m m divided by n. Okay, that's okay, please refer to this page 47. Okay, for example, okay, there's properties of log. Okay, let's say I have the property number 1 is log b m to the power of n. Okay, this equal to log b m minus log b n. Okay, we can divide, we can transform this ratio into the mathematical equation. Log bm divided by n equal to log bm minus log bn. M and n. M and n is a value. Let's say, for example, I have this log 9/2. For example, log 9/2. Okay, this equal to log, let's say log base 10. Okay, let's say log base 10. We can write this as a log only. Okay, remember, this is a log base 10. Okay, this is equal to log 9 minus log 2. If you use your calculator, this is equal to, the answer is 0.9542 minus 0.3010. The answer is 0.653, 6532. And that's how to perform the operation in method. We can convert, if the form of the original log is in ratio, we can convert it into the minus. Log 9/2 equal to log 9 minus log 2. Okay, the next one is about the power. Let's say I have this power. Log Bm to the power of n. Log Bn to the power of n. Okay, this equal to n. We can take n and put this in front of the log. So this equal to n log Bm. We can remove. We can convert the exponential part of the log into the linear. We can make it linear. Log Bm to the power of n. Still n is the power. N is a power for m. That's why we say m to the power of n. Since the equation is in log, we can move the exponential exponential form. The power of the equation, we can move, we can change, we can remove the power, and then we can take the power, and then we put the power in front of the log. Now the equation now become to the linear. No more exponential, no more log in terms of linear. We can we can change, we can remove, we can move the power of we can remove the power from the equation. Now we just write, in other words, we just change the power into the linear equation. Okay, for example, let's say I have this equation. Just for example, let's say I have log, let's say log 2 x, log 2 of x to the power of 3. So this also equal, we can take this power and write in front of the log. So there's 3 log 2 to the power of x. That's how to change the log into the power. For another example, let's say I have this equation: 3 log 2x to the power of x. Okay, let's say I have this. There's another example. Let's say y equal to log 2 of x to the power of x. We have 8 to the power of x. So this also equal to y equal to x. We can take this power. We can take down the power. We can write again the power. We can write the x, the power of x. Now equal to y equal to x times log 2 of x. Because x is up, actually original x is actually the power of x. We can remove the power, and then we can write, we can remove the power of x, the power of the log, the power of the number of 8. We can this power, this operation where we move the power, this only be done in a log function. That's why this is also the main character, the main properties of the log. But the main character of the log, and then we normally we will in mathematics, especially in in a topic 2, 3, and so on. Sometimes we need this rule. We need this property to find the answer. I will show you few examples that related to this properties. Okay, that's about the property number 3. Okay. The next one, you need to know about this. Let's see. I have okay. Log b, y equal log base b of 1. The answer is always 0. Log 1. If you take any log, the answer is 0. It doesn't matter. For example, if you have you, let's say I have y equal to ln1, the answer is 0. Y equal to ln log base 10 of 1, the answer is also 0. That's the another property you need to know. And then the next one, if y equal to log b log base b of b, the answer is 1. Log base b of b, the answer is 1. The value of b is equal to the value of x. In other words, log 10 of 10, the answer is 1. That doesn't make you can justify this calculation by using your calculator. Log 10 of 10. Sorry, log 10 of 10. The answer is 1, because the base has the same value with x. B and x is equal. Okay, another example. Let's say log 2 of 2. The answer is 1. Log 1,000, 100. The answer is 1. And that's for example. Okay, logs bm equal m. Okay, the next one is about the how to change the base. How to change the base of the log. What does it mean? Let's say I have y equal to what is the general form of log? Y equal to log b x. This one. We need b. We need to how to change the base. How to change the base, the value of the base. Let's say, for example, I have this log y equal to log 2 to the power of 7. Now, how to change? Now we need to change b equal to let's say b equal 10. Okay, how to change the base of logs? Okay, there is a formula. You can refer to properties number 9. We have this formula. This is let's say we have log bm. This equal to log am divided by log ab. Okay, that is the formula. How to change the base of log, the log base, the value of b for this from this example. Okay, let's say based on this property, we can apply this example. Let's say I have this function y equal to log 2 of 7. Okay, let's say I would like to change this base. Now the original base b equal 2. The original base is b equal 2. Now I would like to change b equal to. Now I would like to change the base from 2 to 10. Let's say I would like to change b equal 10. Okay, how to change the base of the log? Okay, how to change the base of the log? Okay, based on this example, let's see how to change. Okay, now, okay, the tips is first we need a ratio of 2 logs. Okay, log base 10 and log base 10. We need this ratio. We have to divide this log into the from the normal equation into the ratio equation pada nisbah. So we just write log 10 divided by log 10. Okay, the log This the log 10 of the original value of 7. This one. The log 10 of 7. Divide by the log 10 of the old base, the previous base, this one. The log 10 of 2. Okay, that's how to change the these two log. If you okay, this now the answer is log 10 log okay, now we just change. I did how to change the log base from the log base 2 into the log base 10. So basically we can use our calculator. We can use calculator to find the answer. So I hope you can try to answer this question. Log 10 of 7 divided by log 10 of log 7 divided by log 2. Okay, this equal to 2.80807. That's how to change. Okay, same if you want to change the base, let's say from base 2 to base 5. Okay, this also equal to log base 5 of 7 divided by log base 5 of 2. Okay, that's how to change. We just but we need to convert the equation into the ratio equation, but still in the log. Now we have two log, the numerator and the denominator in log with the new base, where the base equal 10, 10, 5, and so on. Same if you want to change into the natural log. Okay, this also equal to ln 7 divided by ln 2. We will got the same. We got the same answer. ln 7 divided by ln 2. The answer is still the same. 2.80807. That's how to change the log. Okay, there's a few properties about the log. I hope you can refer to page 47. There are another property, but I just focus on the few properties. That properties same to the exponential. We will apply this property in the next topic, especially in topic 2 and topic 3 about the financial mathematics. Okay. There is a few example. I will show you how to solve this equation. I will choose a few example here to show you how to solve the equation. Okay, before that, since there is 12:30, I think we take a break for 20 minutes as usual. Can we take a break or any question before we take a break?
No question.
Okay, we take a break for 20 minutes. We continue at 12:50. Is it okay?
Okay.
Okay, doctor.
Okay, we take a break.